Hi there, this is my third video on getting something to move from a start position to an end position, to delay and then go back to the start position. Let's try it. If I press the button, then it starts the engine moving. The engine moves across until it gets to this switch at the other side. Very crude switch, but it does what I want it to. After 6 seconds or something like that, then the engine moves back again until it gets to its start position, when hopefully it will stop and wait for the button to be pressed again. The switches are a bit big and bumbly, but they suit me for what I wanted. They're actually called reed switches, and the beauty of them is they just have 2 wires. They don't need a supply. It's just a simple switch that works. If we look at the arm, then the arm is very sensitive. No contacts on it or anything. It is just simply a magnet which comes close to this switch which is in here, which is called a reed switch. Maybe we can just see it through the top there. Reed switches are very clever in as much as they are operated by magnets. So if we have a look here, we have a reed switch, which maybe not, I can see. Maybe not. Let's try putting something behind it, see if we can see it better. There we are. I think we can. Oh no, maybe not. We could a minute ago seem to see it. Where can I find it? Come on, baby, you can do it. There we are. Right, so there hopefully we can see the reed switch. Hopefully we can see 2 reeds. It's very difficult to see, but they're not actually touching each other at the moment. Let's try see if we can zoom in a bit. Oh, that's really messed it up, hasn't it? That's messed it up. Zoom out a bit. No. Shouldn't have tried that, but never mind. Shall we pack in? Oh, there we are. Right, hopefully if I can bring my magnet close to my reed switch. Hopefully we can see the reed moving as the magnetic field is through the glass and makes the reeds touch each other. The way I'm using it, the reeds are usually together, so it's normally closed, and then when the magnet moves away, this reeds open, and that affects the circuit. So yeah, using reed switch seems to work well. Quite happy with that. So where do we go to from here? Well, now we want, I suppose, to look at the circuit. If we look at the circuit, what we're seeing is what I've done before. If we look at the pink bit here, then we can see that this is the relay. It has a coil at this side and 2 changeover contacts. The blue one goes from there 0 volts to the positive there, and the green one goes from the positive there to the 0 volts there, thus making the motor travel in different directions. So it stops when it's come in. I've got the in switch here, so the positive no longer goes to the motor as it's coming back in when the relay isn't energized, and stops the motor. It sits there then until this contact moves across, or both contacts move across. This one then becomes positive, this one becomes negative, and in becoming negative, this is no longer in the circuit, but as soon as it's moved away a little bit, this comes back on again and makes contact. It carries on until it gets to the out switch, when the out switch opens, and then the motor no longer, this will be positive because it's come across, this will be negative because it's come across, but once the out switch opens, then it's no longer getting a negative or 0 volt, should I say, supply, so the motor stops working. What we've also got then is this device, this gizmo called the 555 timer. Beautiful little thing, introduced back in the early 1970s, very widely used. It consists essentially of 3 resistors which form a potential divider. These happen to be 5K resistors, so some people say that's why it's called the 555, although that is in dispute. After the resistors, then we've got these things called comparators. They compare the voltage on the plus and the minus. So if we look at this, then how does it work? Well, if the plus, unfortunate to call it plus because I'd consider that positive, but we do have a plus sign there. If that's greater than the minus sign, the minus input there, then the output's going to be high. In other words, it will be near the supply voltage, but if this plus is greater than that. However, if the minus is greater than the plus, then the output's going to go low or near the 0 volts. So to wire these up then, we've got our potential divider, and if we assume that was 6 volts and each of these are the same size, then each one's going to drop 2 volts. So we'd sort of get 2 volts at this point here and 4 volts at this point here. The outputs of these things on their own aren't really very useful, so we put them through a latch. The latch then works that if the set input goes high, then the output goes high. I think I've written it wrong there, but never mind. If that goes high, then the output goes high. So what will make that go high? Well, what we have is it's normally the minus is high than the 2 volts that we'd have on the plus. So therefore the output is going to be low because this is at 6 volts, that is 2, so the output would normally be low. However, when we press the button, then this goes down below 2 volts and therefore the output goes high. The output going high sets the latch and the cue, the output, goes high as well, switching on the relay. So this starts the relay and that relay then starts the motor going until it gets to the out switch. Now when it reaches the out switch, well, what we need to do is to look at the green line. The green line is going to be at 0 volts normally until it reaches the out switch. So normally this will be at 0 volts. So the capacitor down here isn't going to charge through that variable resistor. However, once this switch opens here, the green line is no longer at 0 volts, but it is positive volts because it's come from the positive through the blue wire into the motor, through the motor, nowhere to go down here, but comes round here and makes this positive. Once this is positive, it starts charging the capacitor. The capacitor charges up until it's above the voltage on here, which in the example I'm using is 4 volts. So as soon as the capacitor is above 4 volts, then this positive becomes greater than this minus input, and therefore the output goes high and resets the latch, switching off the output, switching off the relay, and therefore the train goes back out again. Perhaps best to look at that if we can find a little diagram of that, find a graph to show us what's going on. So hopefully this will help. What we've got then is the blue line here is this actually yellow on here. So when I've pressed the start switch, it comes down to 0 volts and goes back up again. This coming down below that positive then sends this high, switching on the output of the relay, which is this red line here. The output then stays on, and once the output's gone high, then these two contacts move across and the motor starts going in one direction until this out switch is opened, whereupon this green line then becomes positive because it connects through there, through that switch, through the motor, and then back round to the top here. That's become positive. It starts charging the capacitor, and the capacitor, which was at 0 volts, suddenly starts charging up until it reaches the voltage on here. Now if we said that was 4 volts, then this, as soon as this gets to something like 4.1 volts, then the output's going to go high, and that is going to reset our latch, and therefore the output is going to go low. As soon as the output goes low, then the motor starts going in the opposite direction, because this out switch now has no effect because the terminal has come back to this positive here. Remember that this switch, of course, is closed until we get to the in part, and this is negative, so it keeps going. And that essentially then is the circuit I've come up with. It only differs from a normal monostable circuit, as they call it, on the 555, in that instead of the variable resistor connecting to the positive so that it would start triggering as soon as I press the button, I brought the positive to charge it back from here so that the motor stops, this goes positive, and then it starts charging the capacitor only when the motor's stopped. Quite a basic, simple circuit. I like it. I think I'm going to actually stick with that as a circuit. If we look at the layout, then what we've got here is the PCB I made. It shows what I've done is to invert the PCB. So we've got our out switch here, our motor here, which of course must be the right way round, otherwise it crashes through the switches. And then we've got the motor in switch here. We've got the relay here with its diode across over here. 555 timer here. Across the top here we've got the resistor to reduce the power to the on LED. 555 itself. We've got the diode that's across the relay contacts with a green LED with a resistor soldered across the diode, so we can tell when the relay's on. Here we've got the pull-up resistor for the start switch, which goes here. Here we've got the variable resistor. Here I've got I think it's 100N capacitor that goes on pin 5 because we're not using that. And here I've got my timing capacitor. I've got my on-off switch up here, a protection diode here, so if power's connected the wrong way around it won't affect the circuit, and here I've got my power going in. So yeah, that's what I've come up with. That's what I think is the best circuit I'm going to produce. It amuses me greatly and I love playing with it. I don't know, I suppose I'm very interested in this sort of thing. You can see the current with the relay and the engine is about 120 milliamps. Once the engine stops, we're about down to 80 milliamps for my relay, and then just about 50 milliamps for the train to go back again. So that should be well within the limits, I think, of these reed switches. So we should be able to get it to work all day without any problems. Taken a long time, mainly because I had problems with the engine. Can't believe the cost of them. So I rebuilt the engine, which has taken a long time, but is the subject of another video. So it's bye now. Bye.